Hello and welcome. My name is Chloe, and along with Georgia, Jordan, and Nicole, we have researched the question, how does natural light and the absence of light affect beans? Throughout our presentation, we will inform you of the current dominant scientific understanding, or CDSU, of the topic, and will give several well-differentiated activity ideas to use within classrooms. We will offer suggestions about specific assessment to implement, and will address the importance of undertaking risk assessments. This aligns with Year 6 curriculum from ACARA, the content descriptor being the growth and survival of living things are affected by physical conditions of their environment, and the elaboration, investigating how changing the physical conditions for plants impacts on their growth and survival. We hope you enjoy our presentation and consider implementing our ideas in your own classrooms. So, why is natural light so important to the growth of beans? Well, beans prefer warm weather, full sun, and require 6 to 10 hours of sunlight daily. According to the CDSU, plants need light as it is a very important part of photosynthesis. Without light, photosynthesis can't work properly, and without photosynthesis, plants don't receive all the food they need to grow. Photosynthesis is the process in which plants produce their own food by combining carbon dioxide from the air with water from the soil. To power this process, plants absorb sunlight, where it is changed into energy to help the plant grow. As previously stated, beans need full, maximum sun. If they do not receive enough sunlight, problems may arise, including decreased growth, plants grow lanky and drawn, leaves are smaller and turn yellow with brown edges or tops, stems become frail, and the bean plant may die. In summary, the CDSU supports the claim that without enough light, plants suffer and are unable to receive all the nutrients necessary to grow. Natural light is imperative in photosynthesis and is therefore vital in the growth of beans.
To engage and educate the students in the science understandings, we would complete a number of activities following the 5E model. If you look to your information pack, you will see an outline of the 5E's plan. To engage the students, the teacher will play a time lapse of a plant being grown before having students think, pair, share, on post-it notes, what they know about the needs of living things, in particular bean seeds, to activate prior knowledge. Activating prior knowledge is important as it allows the teacher to check the alternative conceptions that students have and that will need to be addressed. The students will bring the post-it note to the front of the classroom. The teacher would read out the answers and write the common answers in the knowledge section of the class KWL chart. An example KWL chart and the information on the benefits of using a KWL chart are included in the information pack. To finish engaging students, the Want to Know column will be completed. This allows the teacher to understand what students hope to gain from the experiment and opens lines of communication between the student and teacher. In the Explore phase, the teacher will introduce the questions and ask students to predict what they think will happen. An experiment planner will be given to each student, and the class will work through the causes and effects, hypothesis, research question, materials, equipment and method, as well as designing a table for their observations. An example of the experiment planner is included in your information pack. Experiment planners allow students to follow the correct scientific process when completing an experiment and allow students to organise their thoughts. Students will complete the experiment in their table groups with plants in plastic cups and teacher assistance in planting their bean seeds. A student will be selected to dampen a paper towel and place it in the cup, and the teacher will fill the cup with soil. Another student will be given gloves and selected to place 1 to 2 bean seeds in a cup and will measure 40 ml of water to put in the cup. One cup will be labelled light and the other dark. This experiment is student-led with assistance from the teacher to reduce the hazards involved. Student-directed experiments allow for students to develop a deeper scientific understanding. The cups will be placed in a light and dark space in the classroom, and over the next few lessons, students will observe the plants. To conclude the experiment and complete the explain phase of the 5 E's, The students will write a conclusion and discuss the differences in the plants. One student in each table group will present their results to their peers and the teacher. The teacher will align students' understanding with the CDSU, which Chloe spoke of earlier. There will be a discussion of the results before filling in the What You Learn column of the KWL with the CDSU information.
The 4 different disabilities that this lesson will be catered for are sensorineural hearing loss, nystagmus, the physical disability multiple sclerosis or MS, and fetal alcohol spectrum disorder, FASD. When doing the KWL chart, which was previously spoken about, it is best to have the children sitting nearest to the teacher, as well as having a copy of the KWL chart already printed off for them. For the child with MS, it may also be beneficial to allow them to work on a laptop or tablet, as writing and drawing can be a difficult task. The child with FASD may also need help keeping on task, as this disability typically affects a child's mental ability to learn new things and keep focused. When having the children work in groups to form their hypothesis, perhaps letting the child with SHL work with a teacher's aide or with a scribe will help them communicate what they think and have their input. Doing this will allow the child to still work as part of the team. Another way of differentiating for the students would be to allow the child with MS to use their laptop or for their group's work. Doing this then allows the child with MS to have some control over their group's work, while also being a valuable member to their group. When it comes to pouring the water, the 40 millimeters, and planting the seed, pre-pour the water into a clear container, mark the 40 mils, then empty before the lesson starts. This will then allow the child with nystagmus to be involved in the pouring of the water. With it being clear and only having one marking on the container, it makes it very easy for the child to be able to pour the correct amount of water. Whilst this may seem an easy task, the children with MS and FASD will not find it as simple. So for the pouring of the water, perhaps have the teacher or another group member measure the water. Once the correct amount has been measured and poured into the 40 ml container, allow these children to pour the water into the sprouts. When having the children observe the different growth patterns, it may be best to have the students with SHL, MS and FASD check for their respective groups. In doing this, it gives the children with these disabilities the chance to have some responsibility and an important role in their groups. A teacher or teacher's aide may need to assist the children, but it gives the children a chance to contribute when perhaps they may not have been able to before. Overall, if these adjustments are made, it gives the children the best chance to work as part of their team and contribute to the experiment when they may not have been able to before.
The assessment piece for this lesson is well suited to the activities Georgia explained earlier, as it assesses student understanding of the needs of a plant in an unfamiliar context. During the lesson, we would conduct an experiment on beans following a specific plan provided by Georgia. The assessment gives students the opportunity to develop their own observation template and work with their peers to create a group planning sheet, which includes a hypothesis, materials list, variables, and process. The experiment conducted in this assessment is closely related to the experiment that students completed in the classroom activity. It furthers the student-led learning that occurred in the lesson through the lightly guided task sheet that allows students to not only develop their own experiment, but also makes it easier for the teachers to be able to identify students who have a comprehensive understanding of the topic and those who are simply following the steps and have a basic understanding. The use of grass seeds as opposed to bean seeds makes the differences in understanding clear to see. The openness of this assessment piece allows students to present their understanding in a way that best suits their learning style. In doing so, students are being effectively assessed on their scientific understanding rather than their ability to write, explain, or follow outlined steps. Through the implementation of assessment like this, differentiation is largely catered for. Not only is it based on group work, which allows students to play to each other's strengths, but also gives ample opportunity for high-achieving students to display their full understanding without restriction, and students who need additional support are able to get it from their peers. Students will be marked against a matrix that awards higher marks to students who display more scientifically accurate information that aligns with the CDSU in regards to the needs of plants. The matrix that is included in your information pack provides evidence that students will only be assessed on information that has been covered in the lesson previous, thus creating greater opportunity for student success.
It is important when lesson planning to recognise the potential risks involved and behaviour management strategies that can be implemented. It is vital to incorporate effective risk management processes into planning to minimise the risk of harm to all involved. The risk management process comprises of 5 steps: identifying the potential hazards, assessing the level of risk, deciding on the control measures, implementing the control measures, monitoring and reviewing. Examples of potential hazards and behaviour management strategies within our lesson plan include checking understanding of behaviour management and safety procedures in the lab, reminding students to move safely around the room, to walk and not run, and to be aware of tripping hazards, to safely handle all materials to avoid any injuries, including paper cuts. Students should remain at their tables unless otherwise instructed, and should safely handle all materials. They should not eat, drink, or use materials as weapons. Students should use gloves appropriately and follow hygiene procedures, including proper disposal of gloves. The teacher will supply non-latex gloves to ensure no allergic reactions occur. Students will be told to work sensibly with water, and in the case of a spill, students will be instructed to not move, not attempt to clean the spill, and the teacher should be alerted immediately.
Throughout our presentation today, we discussed activities and assessment that you can implement in the classroom. We also addressed the importance of differentiating lessons and undertaking risk assessments. Our main topic of research was how does natural light and the absence of light affect beans? We hope you have gained vast knowledge about this topic, so if the opportunity arises, you can use this as a resource in your own lessons. Thank you.